So welcome and happy Halloween to everybody. Tonight we're gonna demystify the spooky APIs. We're going to learn about what APIs are, HTTP request, JSON, etc. And then we're going to use those APIs. We're gonna look at some sunset and sunrise APIs, some APIs related to the International Space Station and the Spotify API. A couple of weeks ago when we did our web scraping workshop, I sort of teased APIs at the end. And I told you all that a lot of APIs have the same goal as web scraping, just to get the data. And with everything, there's pros and cons to it. But APIs generally are pretty cool, and depending on the project, if an API is available, it is generally preferred to use. But what is an API? So it stands for Application Programming Interface. And basically, an API is just this concept of this easy, defined way to interact with a system. And it defines the kinds of calls or requests that can be made to the system. It tells you how to make these requests, the data formats that should be used, and the conventions to follow, etc. And if that's not super clear yet, that's okay. We'll go through further and do some concrete examples that'll make things more clear. And you've actually probably seen APIs used before. So if you've ever logged into a website using a Facebook login, a Twitter login, or a Google login, or something like that, you used an API, because those are actually APIs interacting with their system. And this website, whatever website it is actually doing an API call out to Facebook or Twitter or Google to log in using that. And if you've ever done something like link your Facebook to your Instagram so that you can post in two places at once or whatever, that uses APIs too. And so when you make a post on Facebook, an API call will actually be sent out to Instagram to post your Facebook post onto Instagram as well. So who has APIs? And the answer is more and more people, and exponentially so. And this is because APIs are really useful, and people are starting to realize this and act on this. But to be more concrete about it, Twitter has an API, Google Maps and lots of other Google services have APIs, Facebook has APIs, and even Canvas has an API. Professors who are really savvy can use the API to automatically create assignments on Carmen, or even to download the grades for all their students. And just as an example, here's there's lots of sort of directories out there of different types of public APIs, but there's APIs, as you can see, for almost everything. I mean, we've got anime, cryptocurrency, data validation, music, machine learning, et cetera, et cetera. So there's a lot of really cool APIs out there, and a lot of them are public and open and free for anybody to use. So that's pretty cool. And so let's do a little more clarity about what an API really is here. So I'm going to share my other screen here real quick. All right, cool. Okay, so let's see. So to explain the concept of APIs more, basically there's two main entities. There's you and there's the server. And you can interact with the server by sending it a request. And then the server will actually generate a response, and they will send it back to you. And this request here has many things, but there's only a couple things that are required in the request. And those things are a URL and the method of the request, which is basically its type. And this URL is usually on the server. This is where the request goes to. And the method says what this request is. And there's a couple different standard types of methods for request. The most common for data scientists is the get method. And the get method basically just asks, it just says that we're going to get something from the server. We don't want to change anything on the server. We don't want to add anything. We don't want to delete anything. We just want to get information from the server. There's also a post method, which will update existing records on the server, I believe. And there's a put method, which can add new items onto the server. There's other things too, like delete and so forth, but they're not super common, and especially for data scientists. So requests require these two things, but they can also have a couple other things. They can also have a header, and they can have a body. And we won't get into that too much tonight, but do know that they exist and they're out there. But one common thing that they can have is a authentication. And there's a few different ways that you can authenticate with a server. You can do it with an API key. You can do it with a username and password. And you can do it also with this thing called OAuth. And we'll use API keys tonight, and we'll also use just open APIs, which don't require any sort of authentication. The username password method of authentication is pretty outdated, and a lot of APIs don't use it. And OAuth is just a little bit beyond the scope of an intro workshop for tonight. So once we've sent all of this information here in our request to the server gives us a response. And this response has two main things. It'll have a status code and the content of that response. And usually the content of this response is formatted either in JSON or XML. So we'll talk in just a sec about what JSON and XML looks like. And the status code that the response it just lets you know how things went. 200 is usually okay. 400 and 500 codes. So anything really starting with anything in the 400 to 500s are different types of errors. So that's the basic layout there. So transitioning back to the computer. And this is a great time to put some questions in the chat if you have any. Cool. Okay, so as promised, what is JSON besides something terrifying that might come after you on Friday the 13th? It stands for JavaScript Object Notation, but it's a language independent data format. So it was derived from JavaScript, but many programming languages include code that can generate and parse this JSON format data. So for the purposes of usage, today there's nothing that really has to do with JavaScript from a practical purpose point of view. And you can see it's formatted like this. We have the fields. So for this JSON object, we have creation date, modified date, what the name is, and some members for this object. And then we see our data values after this colon here. And it can contain arrays within itself. And so you can actually create some really large data structures in JSON. It's all just text-based like this. Then there's also his somewhat tricky cousin, XML, which just stands for Extensible Markup Language. If you're familiar with HTML, you'll notice that it looks similar. And it also has this structure. We sort of have this sort of tree structure with these larger nodes, and within this larger group of students, we have the individual students, and we see their name and gender. However, don't worry too much about XML, because for the most part, we're going to try and stay away from it. A lot of APIs, you can get back XML or JSON, and it's recommended to get back JSON if possible, because XML is actually harder to parse than JSON, and JSON was just really made for this. There's some more info if you really want, and as promised, here's also the information about HTTP response status codes. The most common one is the 200 for OK. And clicking on this list, yeah, so we can see 200 OK. That's what we want to see normally. But there are lots of bad things that can happen, things that can go wrong. A common one is a bad request for a few different reasons, or unauthorized, forbidden, not found. There's lots of things that can go wrong, of course. The 400 errors are basically the server saying it's your fault, and 500 errors are basically saying, sorry, that's our fault. So without further ado, let's get the R code, and let's see if this will actually still work. And if not, no worries. I will, yep, cool. All right, I'll get that link for us here. Where are notes here? Oh, here it is. Okay. Okay, sorry for the ugly link since OSU's servers are down, but I just pasted the link in the Zoom group chat. And for those of you that are using Zoom on an iPad or something, I will also post it in the our learning Slack. So that's in there too. If you're viewing on your iPad or something and you don't have it on, have the link handy on your laptop. And while we are sending links, I will also send these other links. For your reference. And all right. So here's the full instructions for the R code, but again, remember the link that I just sent is bad. So use the RStudio Cloud link that I sent just a second ago. So I'm gonna do that too. So we can all do it together. And you can log in with your Google or GitHub. And just as a side note, this is using an API to do so. Okay, so you'll click join space. I might not have made that public. Oh, apparently it's public. Oh, yeah. Yeah, okay. So once you go to the PDA API workshop, you'll click on projects and you'll click on the APIs project. It's going to take a second to deploy. Just be patient. There's an increased server load with everybody logging in. And do make sure to not refresh during this part because that will actually restart it. Okay, so once it loads, you should see a couple files on the side here. And if you click on the .rmd one, api_workshop.rmd, you'll see this file pop up over here. And we've just got a couple code blocks in here ready to go. And at the top, we've got our library loading code. And so tonight, we're going to be using two main packages to do our API request. And that's going to be our HTTR library. So that's really the library that's doing the request. And then this JSON-Lite library that we're using is just to actually parse the JSON from those requests. And the tidyverse library is a large data analytics library for R, and we're going to use it to do just a little bit of data manipulation later on. Okay, so our first thing that we're going to try and do is just a basic GET request. No authentication, no queries, no anything, just a simple GET request. And so if we actually look at this link here, we see that this is the Open Notify API, and this is an API for the International Space Station, which is pretty cool. It's just, we see that they have, looks like 3 things that you can call from their APIs. We can get the current location of the International Space Station. We can see when the International Space Station is gonna be overhead, so over a particular location. And we can see how many people are in space right now. So the first thing we'll look at is how many people are in space. So if we click on that link, we see the documentation for this. And a big thing with APIs is being able to read the documentation and understand it. And some API documentation is better than others because some is like really confusing and old and outdated. And some API documentation is really nice and easy to read and formatted. So this is a nice example. And so we see that for there's a couple different types of output. We can get output in JSON or JSONP, and we're just going to do JSON. And so we see this API returns the current number of people in space. When known, it also returns the names and spacecraft that the people are on, and the API takes no inputs. So let's just copy this link here for the JSON output. And you'll see actually they have an example using the jQuery language instead of R to use this API, and they do a GET request to this URL. We're going to do this in R. So we'll see that to do it in R, we just do GET, and then we paste the URL into this. And this, again, this is from the HTTR package. And if you wanted to look at the documentation, you should be able to, actually first we should load our libraries. That would be important, which might take just a second. And then if we search in help, yeah, there we go. We can, now that we've loaded the HTTR package, if this will load. There we go, just a little slow. We see that GET is in the HTTR package, and this is how we use it. So for this example, we just do GET and the URL in quotes here, so as a string. And if we run it by clicking on this code block, we see that we get a response from this URL that we called. We get the date, we get the status, we get the content type, we see that it's JSON, and we get the size. And we see that the status is 200. And if you remember from earlier, 200 means A-OK, so we are good to go there. But where is our data? So let's actually save this as a variable. So I'm just going to call it RES, short for response, but you can call it whatever you want. And if you run it here, we'll see now that there's no output there. But if we look over here, we get data and we have res as a list of 10. And so if we click on it, we can see our response here. And we can see here's the URL, here's the status code. There's some headers that I mentioned earlier. There's this other list with these headers and more headers, and there's a lot of stuff to look out there. But actually what we really want out of all of this is the content. And we see that the content is of type raw, and it's of these values which make no sense to us as human beings. And that's okay. So I'm just gonna create another code block here by using this insert and clicking on R, so I get another R code block. And so if I type in res for our response and then using the $ to access the different subparts of res, we can see what we were looking at earlier here, the URL status code, all of that after this $, this little helper window that pops up. And if we click on content and run it, we see this raw data, which again makes no sense to us. But fortunately, there is a built-in R function called raw to char, and it just takes a raw vector, which is what we have here, and converts it to a character vector, which is something that we should be able to make sense of. And so if we take this character vector and run it, we make it into a character vector, and we'll see here that this actually looks very similar to the JSON code from earlier. There is all of this, these additional like quotes and backslashes and stuff, but that's just string formatting things. And we can actually see this JSON or JSON to properly pronounce it, I suppose, and not get this evil spirit of JSON coming after me. We can actually get this into a proper JSON object from the JSONLite library. And to do that, we can actually just run the from JSON function on this. And so running again, we actually see, okay, we get this sort of vector, and we see that there's 6 people in space. We get a success message because the request was successful. And then there's this people thing. And so we get this vector, this data frame. And we can see the 6 people that are currently in space right now, and they're all on the International Space Station. Okay, so it's your turn now. I've put the link here in R for another part or another API call that you can do to the same API call. So just, I'm gonna go back in breakout rooms and just try and do an HTTP request, do a GET request to this, the URL for the JSON, and get it back in a some sort of properly formatted thing, just like what we did earlier. And I'll give you 3 minutes. Go. All right. Welcome back, everybody. All right, so we'll just go through the solution here real quick. So I'm just going to go ahead and make a variable. Maybe we'll call it res2 for response2. And looking at this documentation, I can see that because we're just asking for some data, it's just a GET request, and it gives us the URL for the JSON response is this. So I'm going to copy that. I'm going to do a GET request with this URL. I'm just going to print out the response, and if I run this code block, we'll see I get a 200 response. Cool. That means it worked. And let's see what the response is. So I know that I'm going to need to do our response, well, response2, and go to the content, because that's how it's formatted. I see, oh, it's a raw string. So I'll do raw to char on it. And I see that now I get this JSON looking string here. And so I can use the JSON library to call from JSON on it. And running it again, we can see that at this current time, here's the timestamp. Here's the latitude and the longitude of where the ISS is above Earth. All right. But what happens when we want to give the request some data and ask for some data back? So we actually have to use a query there. And so if we look back at Open Notify and we look at the pass times, we'll see that there's actually to this. And so because if we give it a location on Earth, this API will compute the next n number of times that the ISS will be overhead. So if we look at our input here, we have our lat, our long, our altitude and number, and we see that only 2 of these are required. So for the moment, we'll just worry about those 2. And we see here that for our JSON output, there's this link. So I'm going to copy this link, and I'm going to go ahead and do a get and put it like that. Now, of course, I can't just, you know, run it like this, because we'll actually get a status code of 400, which if we look back at our Wikipedia page, we see 400 is a bad request due to an apparent client error, aka we did something wrong. And here it's fairly obvious, we didn't actually give it latitude and longitude values. So if we want to know when this is going to pass over OSU, we can actually just take the coordinates of Ohio State that I went ahead and put into the doc here. And if we rerun, we'll see status 200, good. And it actually will start to spit out some of the response there. And if we do the same thing that we did earlier, this assigning it equal to the response or some other variable. I should have done an API about trains, but it's too late. But if we can see here, we get our JSON, and here's our latitude and longitude that we gave it to it, and it gave us the default number of 5 passes. So, well, I guess maybe the default's actually 4. But so we get 4 rows here, and we get to see how long and at what time this is going to be. And so this is actually, this time is of a standard, the UTC format. And without getting into that too much here, we can actually just do a little quick conversion to see like what time is this actually, when is this actually, because this time format they gave us is really for computers to understand, not humans. So if we just make a variable, and we'll call it our time data frame, we can, let's see, so let's assign this actually also to a variable. We'll just call it our JSON res underscore res. And if we look at this, we get a list of 3. And we see that the data frame that we're looking at is called response. So if we want to get our time data frame, we're going to do our JSON res, and then we're going to get the response out of it. And so if we run that code block, we'll see that we make this time data frame over here. And so that we get the same thing from before, but just actually as a data frame object. And if we want to do just some quick tidyverse magic that I don't have the time to fully explain in this workshop, but I'll send the code in the chat in just a minute. We'll use mutate to make a new variable for our time data frame. And we're going to call it something like rise time formatted. And so that's just what we're going to call our new variable in our data frame. And we're going to use the package lubridate, which is from tidyverse. And we're going to use this function as datetime. And we're going to run it on our variable rise time, which was here. And so if we run that, we'll see that we get this time data frame with duration or rise time, and then our formatted rise time. So now we can actually see that the next time that the ISS is going to pass over Ohio State is going to be tomorrow at 3:23 a.m. So set your alarms, everybody, for 3:23 a.m. tonight if you want to see the ISS. I'm assuming you probably can't see it. So I'm just going to send that in the chat real quick because I know I went fast on that since this isn't really quite part of the topic of the workshop, but I did want to show that a lot of times you can make this data very useful. On your own time, just for the sake of time, here's an example that you can use to get the sunrise and sunset time of particular coordinates. But just for time's sake, we're going to skip on that for now. So there's one other type of request that I want to touch on tonight, and this is a GET request with API key authentication. And this is a very common thing to do as well. And so if we look at documentation here for the Spotify API, there's all of this documentation and things. But basically, to do this tonight, you just need to have a Spotify account. And if you don't, that's okay. You can just kind of follow along. But most, if for APIs that require some sort of authentication, you usually do have to make an account. So the second link here is also part of their documentation, and it's this search. So you can use this API to just search Spotify without being on Spotify. And this could be useful if you want to do some sort of large song related study and you want to search for a bunch of songs which might be related to your study. So if we wanted to search for something like Muse, who's one of my favorite artists, we could do this. And Spotify's API documentation is nice because it's actually kind of showing us how to format this response. This is as a curl request, which is how you would send it in the terminal. And we can click get token. We don't need to ask for specific scope. It's going to ask me to log in. I think this is the account that I use for Spotify. Pretty sure it is. Nope. Maybe it was this one. Oh. Well, I know I'm logged in on my other tab window, so I'm just going to go there. So yeah, actually, and it already gave me a token because I'm Already logged in here. Cool. Okay, so it'll ask you to log in there. And if you do this, you'll see that we get this OAuth token. And generally speaking, whenever you generate an OAuth token, this is something that you're going to want to keep secret. But I've used the Spotify API before, and I know this is going to expire within like 10 minutes or something. So it's pretty much fine to show this since it's going to expire really quickly. And so Spotify's API is nice, and it tells us if we send this in terminal, because this is just the curl request, and so I could show, just copy and paste, we get this JSON response back for this song search. But let's do this in R, because we actually want to get this data in R, right? So we can see from this formatted curl request here that it's a GET request and that this is our URL. So I'm going to copy the URL. Actually, I'm going to copy it with the quotes. And I'm going to go back to my code here. And I'm going to do a GET request. And I know that this is the URL. But again, if I run this, I see status 401, no token provided, and that's because I didn't actually finish the request yet. So I'm going to go back and I'm going to see that, okay, so the way that they formatted this kind of request is through this -h, which stands for header here. So this is actually part of the header. And in this header, it says authorization, bearer, and then the OAuth token here. And so what we do to do that, so I'm actually going to, so if we go back to our R code, we actually have to add a header to this. So before I do that, I'm just going to save my Spotify OAuth token in this variable here. And so I'm just going to copy, I'm going to copy everything. I'm going to copy the bearer and the token, because that's going to be the entirety of the authorization header. So I guess I should really name it Spotify OAuth, just for better clarity there. And the get function, going back to our documentation, has something called add headers. And it's part of the config argument. So what we can do here is we can add a config argument. You can say config equals add headers. And I've looked at the documentation for this as well, so I know that it requires a list. And we say it's just a named list, so we want to say, okay, our authorization, and what is our authorization equal to? It's equal to our Spotify OAuth header. And hopefully, if we run this, yes, it will work. And I'll send the code real quick just in case you missed that. And so we can actually do the same thing from before. We can save this as a response, and we can just copy and paste our code from earlier to get our JSON response. And we'll run that again, and we'll see we get our JSON response artist, and we get a list of link 7, and we have the URL that we called, and several items in here. And so we have all of these data frames in here actually. And so we'll see that, like, if you just click this, you can get in the console how to get to this element in the JSON list that we create. And if you hit enter, you can run it. And so we see that we get this big data frame here. We get this unique artist link that Spotify generates. We can see how many follows or followers each artist has. We can see some of the genres that they're classified as, chamber psych. Again, the URL, the ID. You can even see some images. And actually, if we just even try and go to this random image link here. Yeah, we see this image for that artist. And yeah, so we get a lot of information here just from a very short call. And I think you could probably easily see how this could be extended and called a lot and build up this big data frame with lots of information to do analyses on. There's another GET request example where you can get do an audio analysis of a track. And for the sake of time, I'll just send a link to the code in the BDAA Slack later with the solution. But you have 2 examples to try on your own. And like I said, I'll send out the solutions. But that's really the end of the workshop for tonight. And if you have any questions, I'll be here. But otherwise, there's the BDAA Slack, our learning community, where you can ask lots of questions on. And my contact info, you can always message me on Slack or through my website. And yeah, like I said, I'll be here for questions. But otherwise, thanks for coming out to the workshop tonight. I hope it was helpful, and I hope all of the workshops have been helpful to you. And yeah, have a good night and happy Halloween.